Hello, ma'am. My name is Jali Manoj Kumar. My topic is security and reliability in high performance computing environments as research paper. What is HPC? High performance computing environments. It is also known as supercomputing environment, e-science environment, or cyber infrastructure. It is a crucial system that connects user applications to supercomputers and provide usability, efficiency, and sharing and collaboration capabilities. Examples of HPC environments are extreme science engineering discovery environment, which is present in the USA, European grid infrastructure, European Japanese computational grid research project, Chinese national grid. Many different use cases, many different academic, industrial, and government organization use this new HPC environments used to model complex problems in many areas that need massively parallel computation and throughput. Example in weather prediction, bioscience, applied physics, nuclear, geology, and defense. Industrial and commercial sectors are becoming a significant driving force behind the evolution of this HPC. The commercial applications require the processing analysis of very large amounts of data in sophisticated way. So they use these HPC environments. HPC ecosystem. Uh, the stakeholders in this HPC ecosystem include academic computing, national laboratories, industry, defense, R&D. For operational problems such as weather prediction, traffic control, and transportation, we use here restrictions on operator use may depend in part of the regulatory environment, whether there are legal obligations to provide security for sensitive information. HPC may support critical infrastructure with requirements for continuous availability, and therefore operator restrictions may be greater. Similarities between the HPC and traditional IT systems. They both are on the surface connected to IP networks, and they often work on like a operating system like Linux. They have similar hardware, software, and configuration challenges and flaws as other systems. Differences between the HPC and traditional IT systems: high performance computation and data transfer. Also, many HPC systems like NSF, DOE, ASCR are extremely open, including international collaborations. We can't use certain security solutions such as network firewalls in the same way. Security that impedes collaboration or reduces usability hinders science. Some solutions exist that can help compensate for these constraints, DMZ science, which we'll discuss in later. We need security without the more simple approaches such as firewalls and air gaps. Science DMS. This solution will help compensate for the constraints mentioned above. The security model optimizes network throughput, isolates sites scientific computing in its own network enclave, direct transfer single networking point that can be monitored and restricted. Example like router ACLs achieves throughput by reducing complexity. HPC systems tends to have very distinctive modes of operation. Um, it is used for very distinctive purposes, notably for mathematical computations. It runs highly exotic hardware and software. It is extremely open to users. This distinctiveness presents both opportunities and challenges. Security opportunities. Monitoring data is one of the monitoring data is useful for security monitoring for abnormal behavior, misuse of cycles, identifying manipulated programs. Also useful for provenance integrate monitoring. But the ability to successfully perform analysis on monitoring data depends on the availability of useful monitoring data. Custom stacks provide opportunity for instrumenting system, hardware or software to capture Additional audit providence data. Conclusion. HPC systems used for distinctive purpose and have strong regularity of activity. Trend towards continuous operation and limited interfaces in HPC is likely to help. As we discuss various security risks practices in this study, with the rapid growing of HPC systems in terms of both scale and complexity, machine learning based security inspection, evaluation, and malicious behavior detection will play a more important practical role in improving the usability and security of these HPC systems. Thank you.